STEM racing is an incredible challenge, but before you can even start designing your car, you have to master the technical regulations. In this video, we'll break it down step by step, how to read the rulebook, and what the most important regulations are, and how to actually apply them in your design. Let's get started. The technical regulations are the official rulebook for building your car. Everything from your wheel size to your car shape to what materials you can use is defined here. The rules are split into 10 articles, T1 through T10, and each one focuses on a different part of the car. There's also an appendix at the end of the document with diagrams and examples. Most importantly, the rules are categorized into 3 types. General, which define how the car should look and function. Safety, which must be followed for your car to race. And performance, which affect how fast your car is. If you break any performance regulations, you're out of the running for fastest car or best engineered car, and you'll have a time penalty added to your seating in the knockout tournament. When reading a rule, don't just look at the number. Pay close attention to the penalty type, whether it's marked general, safety, or performance, and whether it carries a proportional penalty. Let's take an example. T3.6 in the 2025 World Finals regulations says your car must weigh at least 48 grams. If you're even 0.1 grams under, you'll get a 10-point penalty per gram underweight and be forced to add ballast at tech inspection. See how some rules say absolute min or absolute max. This means there's no wiggle room. Even a tiny violation counts. Another important detail, the diagrams are only helpful, but only the text of the regulation is binding. That's in T2.2.1. Once you understand the rules, the next step is applying them to your CAD design. Start by sketching your car's legal boundaries. Use reference planes A and B to mark where the nose cone and rear wing start. Include the power unit cartridge, the virtual cargo volume, and the wheel exclusion zones as bodies from the very beginning. Add your halo and helmet using official files. The halo is mandatory, as per T4.4, and it must be visible in top, side, and front views. Also make sure to model the halo pocket, the recess that allows it to sit flush. It's designed to be machined with an 1/8 inch or 3mm ball nose end mill. Another essential constraint is track clearance. Every component must be at least 1.5mm above the track surface, except for the wheels, of course. Your engineering drawings are nearly as important as the design itself. As outlined in T1.15, your designs must clearly dimension components like your wings, wheel supports, nose, and virtual cargo, use hatching, shading, or color to show where regulated zones exist, and to include rule references. I usually prefer putting the T number in brackets next to the dimensions. Good drawings make scrutineering easier and reduce your risk of point deductions. If a scrutineer has to guess, you're more likely to be penalized.